Program learning, also known as programmed instruction, is a method of teaching or training that presents information in a structured and sequential manner, allowing learners to progress at their own pace. It was popularized in the mid-20th century by educationals, psychologists like B.F. Skinner, and is based on principles of behaviorism. Here are the key features of program learning. 1. Sequential and structured content. Information is presented in small, logical steps called frames. Each step builds on the previous one. 2. Active learner participation. Learners must respond actively at each step, for example, answer a question or solve a problem. This increases engagement and retention. 3. Immediate feedback. Learners receive instant confirmation if their response is correct or incorrect. This helps reinforce correct answers and correct mistakes quickly. 4. Self-paced learning. Learners progress through the material at their own speed. This allows for personalized learning and reduces pressure. 5. Reinforcement. Correct responses are positively reinforced to encourage learning behavior. Reinforcement is a key principle from behavioral psychology. 6. Mastery-based progression. Learners move to the next step only after mastering the current one. Ensures a solid understanding before advancing. 7. Evaluation and feedback for improvement. Learner performance is continuously monitored. Can be used to refine the instructional material based on learner data. 8. Error control. Frames are designed to minimize the chance of errors. In branching programming, incorrect answers guide the learner to remedial material. These features make programmed learning a powerful tool for foundational skill development and structured knowledge acquisition. There are 3 main types of program learning, each with distinct characteristics and instructional approaches. 1. Linear programming. Developed by B.F. Skinner. Features. All learners follow the same sequence of instructional steps. Content is divided into small frames. Learners must respond to each frame and receive immediate feedback. Progression is step-by-step and mastery-based. Advantages. Simple and easy to implement. Ensures uniform learning outcomes. Limitations. Lacks flexibility for different learner needs. Not ideal for complex or creative subjects. 2. Branching programming. Developed by Norman Crowder. Features. Learners follow different paths based on their responses. Each question offers options. Wrong answers lead to remedial frames. Focuses on diagnosing misunderstandings and correcting them. Advantages. More flexible and adaptive. Provides differentiated learning experiences. Limitations. More complex to design and develop. Can be confusing if not well structured. 3. Mathematics programming. Developed by Thomas F. Gilbert. Features. Focuses on teaching complex tasks by breaking them into simpler components. Emphasizes strategies and principles over rote responses. Often involves backward chaining start from the desired behavior and teach steps in reverse. Advantages. Effective for teaching problem solving and critical thinking skills. Promotes deep understanding and skill mastery. Limitations. Requires more effort to design. Less suited for simple fact-based learning. Here are some examples of programmed learning in different educational contexts, ranging from traditional to modern implementations. 1. Linear programming. B.F. Skinner's model. Example, a workbook or software where learners answer a question, receive immediate feedback, and then proceed to the next step in a fixed sequence. Context, common in early math or grammar instruction. Tool, teaching machines originally used for drilling arithmetic or language basics. 2. Branching programming. Norman Crowder's model. Example, an e-learning module that offers different paths based on the learner's responses. For example, incorrect answers lead to remedial content. Context, suitable for complex subjects like science or medical training. Tool, diagnostic quizzes that adapt the path based on understanding. 3. Language learning apps. Example, Duolingo. How it applies, uses program learning by presenting bite-sized lessons, instant feedback, repetition, and adaptive review sequences. Features, gamified experience, reinforcement of correct answers, personalized learning pace. For math practice platforms. Example, Khan Academy. How it applies, learners watch videos and then answer practice questions with immediate feedback and recommendations for what to study next. Features: mastery-based progression, automated hints and explanations. 5. Computer-assisted instruction CAI. Example: Plato System early computer-based education system. Howard Uplies, authored subject-specific programmed lessons, used widely from the 1960s-1990s. Features: integrated multimedia, feedback loops, branching learning paths. 6. Interactive tutorials in coding platforms. Example: Codecademy, FreeCodeCamp. Howard Uplies, students receive step-by-step instruction, complete coding tasks, and get immediate feedback before moving on. Features: programmed instruction with built-in assessment and adaptive learning tracks. 7. Self-instructional modules. Example: nursing or technical training modules, often PDF or web-based. Howard Uplies, presents objectives, content, practice questions, and feedback in a sequence. Features: often used in professional development or certification programs. 8. Educational games and simulations. Example: Oregon Trail, Typing Club. Howard Uplies, learners progress through levels or scenarios only when mastery is demonstrated. Features: feedback-driven, often includes branching choices based on learner input.